to solve search suggestion system. This question teaches you more on binary search, and this question has been asked in Google, Meta, DoorDash, Amazon, Salesforce, Oracle, Citadel, lot of big tech companies, right? And it's a very cool question to understand more on binary search, when it how it can be used on strings also, so as uh, like before, the goal of this video is to help you understand where and when you can use binary search, right? And how will you know that a question can be solved using binary search? Okay, so going straight to the question. Okay, so the question says you are given an array of strings products and a string search word. So you have a word and you have an array of words, right? String products, and these are like products, right? You want to design a system that suggests at most three product names from product. You want to design a system that suggests you at most. So maximum word suggestion should be less than equal to 3, right? Suggestion word should be less than equal to 3. Okay, if 1, 2 and 3 we have done, our suggestion are there, count is 3, then yeah. Right, after each character of words types, search word is typed. So after each character, so I have typed 1, I have typed 2, I have typed 3, right? So after each character word has been typed, you want to suggest an answer, right? Fine. So after every word, so I have typed A, then I have typed for A how many prefixes are matched, then AB how prefixes are matched, then ABC how many prefixes are matched, like that. And then if there are more than 3 products with a common prefix, you want to return the 3 lexicographically minimum products. So this is the core of the question here. So let's say that you have 5 words, all it's starting with A, and when you type A, you have to find the first 3 words that are lexicographically smaller when compared to these 2 remaining, right? So when I say lexicographically, it means if you arrange every word or every word from that array, it should be in a non decreasing order, so it should be in an ascending order, you can say, right? Okay, so now coming to the example here. Example says mobile, mouse, money pot, monitor, mousepad, right? So the first hint that I got from this question is it clearly says that it wants lexicographically smaller. Lexicographically smaller. That means the ascending order sorted, right? So you can just directly sort the given array. First, step 1, very important step 1 is you sort it. Now you have a search word mouse. Each time you type, each time basically you loop around or iterate around, it should collect the prefixes as well together. So first you test with M, then you test with MO, then you test with MOU, then you test with MOUS, and then you test with MOUSE. Correct. Okay, yeah, fine. Now going ahead here, so I just want to store all, and then I want to find 3 words which are lexicographically smaller, right? Minimum. Okay, so when I type M and after I have sorted, these are the 5 words that I had. Can I say that when I'm here and it's already sorted, can I collect these 3? Yes, I can say that. And then I will input it into my suggestions list, right? Now I have already collected these 3, done. I can move ahead, right? I can move ahead to MO also. This one matches, I can pick up the 3 because it's already sorted, and I added it to my suggestion. Now when it comes to MOU, I'll check with this, I'll check with this. Okay, MOU matches. I can collect 3 if it is there. Otherwise, if my index is in between or less than the product range and I don't have any suggestion, then I'll pick up this 2, right? I'll iterate over till here. Okay, fine. But you saw, right, when this input increases, it will be a trouble to iterate over each products, iterate over each products, right? Why can't I directly jump here, or why can't I directly jump here? Is there any algorithm that will help us to jump here efficiently? Maybe on a point, right? Maybe on a point. Yes, there is. We can use binary search, right? We can use binary search. How we will use binary search? Like binary search suggests that you find a left, you have a left, you have a right, you find a middle, you compare your target with a middle. If the target is bigger than the middle, you find in the right side space, otherwise you find it in the left side space. That's how normally it works, right? And if the target is equal, then voila, you return m. But here you don't want just to return the middle one, right? It can start from the middle one also. Okay, one core thing here. Also, you want to find a valid minimum answer space, valid minimum valid answer values basically, right? So minimum valid value, minimum side is the left side, right? The left side is lesser than the right side. Minimum valid answers, right? Lexicographically small. Okay, so how the algorithm will work here? So first I will type m, I'll have m, then I will do a binary search here. I'll check m. Okay, I'll check with this. If m is smaller, yeah, m is smaller, right? M is smaller than the middle. So I'll check on the left side space. Right? Now I'll check on the left side space. So I check left side space. So I'll have 2 again. Okay, middle one will be this one. Then again I'll check if this is lesser. Yeah, still m is lesser. Okay, should I check the left side space? Okay, I try to check the left side space, but I can't go ahead. So what I will do is, whatever my leftmost was, because this could be the minimum one, right? Minimum one here. I'll just return its index. So I'll have a start index. Okay. Now I have the start index is I1. Okay. Now I'll start from here, but I'll only go till the 3 points, right? I'll only want 3 products in the answer, right? So what I will do is I'll check. I'll check if my index is within the range of 0 to product length. If it is in the range of 0 to product length, and whatever I am collecting in my suggestions list, right? Is it less than 3? Why less than 3? Because suggestion will initiate from 0. So 0, 1, 2. So this is total up to 3. So that's why I am comparing it with the integer 3. If this condition satisfied, I will add these 3 words in the suggestion, right? Okay, so same thing will happen for MO. For MOU it will not happen, right? Because so for MOU, what will happen? So I'll have a pointer here, I will again have a pointer here, I will again have a pointer here. Okay, so MOU is clearly bigger than MON, right? Lexicographically. And how will I compare this? These strings? I will use a compare to operator in Java. Okay, so if it is more, I want to see the right side space. Right? So my left will come here. Again, these 2 things, middle one will be this. I'll compare with MOU SE. So MOU again will be less. If it is less, I'll look in the left, right? It will come here. I'll pick middle, and then I'll just return, because now it will try to cross. So I'll just return the left start point. So now my start point is here. My start point should be in the range of 0 to product length. Yes, it is in the range of, and my suggestion should be empty. So I'll start from here, and then I'll come here. It is still less than. Okay, I cannot do increment, and my suggestion is also. So I'll add it to suggestion is still, but I cannot go ahead. Right? I'll have to do an AND condition here. Right? I'll add it on my suggestion list. Okay, fine. And for MOUSE also, it will do the same thing. Okay. Now going to the code here. Okay. So first thing first, or like I said, we have to sort. right? We'll have a final result array that we can create using this return type. We'll have a prefix where we will store the character word character by character, right? String prefix where we store character by character. Okay, now I'll iterate over this product. uh, I have to iterate over this product list, but I want to iterate over the search word one by one, so we use this. So I'll just concatenate and take the first word step by step. Then I'll try to find it within the product range. So here I have used lower bound binary search because we want to return the minimum valid value, which will be always on the left side. Lower bound. Lower bound will take the products and the prefix, whatever I am trying to search. It will have two pointers like left and right, right? And until and unless they cross each other, I'll just iterate. I'll find the middle. I'll use the compare to. So the middle one, if the middle one is lesser than what I am trying to search, if it is lesser than what I'm trying to search, things will exist in the right space. So left will become, so left which was here will become come here. Otherwise, I'll want to check on the right side space, but the middle one could also be the answer. So right equals right becomes middle. Then eventually when left and right in crosses each other, right, I'll just return the left. I will just return the left. So this will be my starting index. This will be my starting index. From there, I will have to check if the current index that I am in should be less than the product's length, should be less than the product's length. And my suggestion should not have more than 3. My suggestion array list should not have more than 3, because this is the suggestion that I am going to finally add in the result answer. So that's what I am doing. I am adding the product in my suggestion and then my suggestion in the result answer. Right. So that's it actually. That's how you can solve this question, right? And you'll need a break statement because it is sorted. No further match, when no further match is possible, because for the 2 scenario, right, last 2, it will try to iterate, right, but you want to break. Yeah. So the observation here was the answer said lexicographically sorted, and when we try to sort it, right, we will see that the answer space is sorted and it shows a monotonic behavior, right? Whenever I search, it will always be, so let's say whenever I was trying to search for mouse, for MOU, these two are true and the other will be false. And in my previous video, I have showed you that if such kind of behavior exists, it's a clear hint of using binary search. Second is, whenever there is a ask of minimum valid value, you just want to return the left. In this case, your left will become middle plus 1 and your right will become mid. Right? Your left will become middle plus 1 and your right will become mid. Okay, for lower bound, right? Okay. Yeah, so that's it for today. I hope you understand the question. If you understood, please like the video, comment if you have any doubt. I'll really try to solve it. I'll create a short maybe, right? Okay, thank you.